Imagine stepping inside this perfectly sealed, windowless stone vault,
Right?
and you play a single, perfectly tuned C major chord.
Just one chord.
Yeah, just one. And as the sound waves bounce off the walls, you watch as the physical gravity in the room well, it just dissolves.
You're completely weightless.
Exactly. You feel weightless. And then, you open the vault door, you step back outside, and 1,000 years have passed.
It sounds totally crazy.
Sounds like science fiction, right? But today, we aren't talking about sci-fi. We are tearing apart this massive 15,000-word physics manuscript that claims this exact scenario isn't just like mathematically possible. It claims it's already been done.
By Noah's Ark, of all things.
Right, by Noah's Ark. So for you listening right now, whether you're prepping for a deep dive discussion on fringe theoretical physics, or maybe catching up on alternative scientific frameworks, or, you're just insanely curious about the fundamental nature of reality, this is your shortcut.
Your mission briefing, basically.
Exactly. We are diving into a manuscript called Time Travel Transdimensional Unified Field Theory version 5, or TDUFT for short.
Written by George James Dukas in 2025.
Right. And our mission today is to distill this highly technical, very dense document down to its most mind-bending core. Because Dukas is making this wild claim that time travel isn't, moving a physical machine backward or forward through spatial dimensions.
No, he says it's a navigable journey through what he calls a memory lattice.
A memory lattice, which is just, wow.
Yeah. And to really appreciate the stakes here, I mean, we have to look at what TDUFT is proposing to replace. Because it doesn't just offer some, slight correction to Albert Einstein's general relativity.
Right, it's not a tweak.
No, it throws relativity out entirely. In this framework, gravity is not a fundamental force of nature at all.
Which goes against everything we learn in school.
Totally. Gravity is merely a byproduct. It's like an emergent property of something the author calls time density.
Time density. And, the text doesn't just offer this abstract whiteboard math. It actually brings receipts. It claims that the highly documented time shifts we observe in GPS satellite clocks.
The ones we always attribute to Einstein.
Right, exactly. It claims those shifts actually prove this alternative theory exactly, like down to the decimal point.
It's a huge claim.
It really is. And then it makes this astronomical leap to say that ancient megastructures like the Great Pyramid and Noah's Ark were literal, functional, harmonically tuned time machines.
Which we're going to get into.
Oh, we are definitely getting into it. We're going to start with the foundational physics of TDUFT, then move through those ancient geometric blueprints and take you right down to the actual engineering specs for a backward time-traveling spaceship.
But before anyone can, build a time machine, really have to establish what time and gravity actually are in this alternative universe.
You have to redefine reality first.
Exactly, yeah.
So let's unpack this. In the TDUFT framework, time is not just a single ticking clock. It's not a river flowing in one direction. It actually has two foundational layers.
Right, the dual layer concept.
Yeah. So first there is T, which is the linear time flow. This is basically how fast events unfold, the clock rate.
You can think of the T parameter as the flow layer.
Right.
It's the rate at which a local region of space experiences external history.
Okay.
It's the forward progression of causality itself.
And then there's the second layer, T squared, which Dukas calls density time.
Right.
This is the capacity of a region of space to actually store memory or history. So we have flow and we have density. And I was trying to visualize this, and the best analogy I could come up with is an old school vinyl record.
Oh, I like that. Yeah.
Think of T, the linear time flow, as the speed the record is spinning on the turntable.
Like 33 RPM.
Exactly, 33 RPM. It's the rate the needle travels across the surface. But T squared, the density time, is the physical depth, the complexity, like the width of the grooves themselves.
The actual information.
Right. It's the physical capacity of the vinyl to contain the music, the memory of the song.
That vinyl analogy actually perfectly captures the dual nature of this TDUFT universe.
Oh, good.
Because the T is the speed of traversal,
Yeah.
but the T squared is the informational volume. You need both to play the music of reality.
Because a spinning record with no grooves is just a flat disc.
Exactly. It has flow, but it has no memory. And a stationary record with deep grooves has memory, but no flow.
That makes so much sense.
Right. And this relationship brings us to the absolute bedrock of the manuscript,
Yeah.
which is the gravity postulate.
Okay, lay it on me.
The author states that gravity, G, is equal to 1 over T to the fourth power.
Okay, so G equals 1 over T to the fourth. Let's translate that into plain English.
Sure. It establishes a strict inverse relationship between time density and gravity,
Inverse meaning.
meaning where time density is higher, gravity is weaker.
Oh,
They are fundamentally tethered together. So if you increase the time parameter, t, in a local area, the physical force of gravity in that area exponentially collapses,
so they're basically opposite ends of a seesaw.
pretty much.
But wait, I want to drill into the proof here, because the manuscript claims this inverse relationship is proven by our own modern GPS satellite.
The atomic clocks, yeah.
Right. We know that atomic clocks on GPS satellites in orbit tick slightly faster than identical clocks down here on the surface of the Earth.
And mainstream science has always said, that's Einstein, that's relativity.
Right. The mass of the Earth curves space-time. But TDUFT says no, it's not curvature at all, it's time density.
What's really fascinating here is how TDUFT calculates this exact clock shift without using a single principle of relativity.
None at all.
None. You have to picture the universe not as an empty void, but as a physical structured grid, the memory lattice.
Okay, visualizing a grid.
So the Earth is this incredibly massive body. And according to TDUFT, the physical mass of the Earth actually compresses or thins out this memory lattice at the surface.
Oh, because it's so heavy.
Right. Because the lattice is crushed by the planet's mass, its ability to store information drops.
So the time density is lower.
Exactly. But as you move away from the Earth, up into orbit where the satellites live, the mass influence fades,
The lattice is less compressed.
which means the time density is higher.
Higher up means higher time density, which means a larger t. And because g equals 1 over t to the fourth, a larger t means a weaker effective gravity.
You got it.
So the clocks aren't running faster because they are moving fast or because space-time is curved.
Yeah.
They're running faster purely because they're sitting in a thicker region of the memory lattice.
And when you look at the math, that is exactly what falls out of the equation.
It's wild.
The TDUFT calculation starts with the geometric vacuum value of gravity, looks at the mass gradient of the Earth, applies this time density amplification, and it predicts a clock shift of 5.432 times 10 to the negative 10.
And the actual observed GPS clock shift measured by engineers is 5.313 times 10 to the negative 10.
Which is a 99.8% match.
It's incredibly close. But let me pause you right here because I really have to put on my skeptic's hat for a second.
Go for it.
If this theory is the ultimate unified truth of the universe, and it's an exact theory, as Dukas claims, what about that remaining 0.2%?
The variance, yeah.
Right. Why doesn't it match perfectly? And furthermore, the manuscript mentions that the true theoretical geometric gravity constant, what it calls G0,
Right, G0.
is about 2.7% different from the standard gravity constant we actually measure in modern physics labs.
Yeah, the big G.
So how can a theory claim to be a perfect reflection of reality if it's off by 2.7% in the lab and 0.2% in the sky? I mean, it feels a little like hand-waving away the errors, you know?
It's a really vital critique, and it speaks to the limitations of how human beings actually measure reality.
Okay.
The author explicitly addresses these discrepancies, arguing they aren't math errors at all. They are the physical result of something called harmonic attenuation.
Harmonic attenuation, meaning like the signal we are trying to measure is getting muffled somehow.
Kind of.
Mm-hmm.
Think about what it takes to measure gravity in a modern laboratory.
It's a huge setup.
Huge. True, unperturbed gravity, G0, is a geometric constant of the vacuum lattice. It relies on the full, unconfined resonance of the entire universe interacting with mass.
Right.
But how do we actually measure gravity? We use highly delicate torsion balances. We lock them inside these thick metal vacuum chambers. We build massive electromagnetic shields around them to block out stray radiation.
So we isolate the experiment from the rest of the universe.
Exactly. And by heavily isolating the experiment, by putting all these physical boundaries around it, we damp the higher harmonics of the memory lattice.
Oh, I see.
Consider a massive bronze bell. If you strike that bell in an open field, it rings with this rich, complex set of overtones.
It's loud and clear.
But if you wrap your hands tightly around the bell and strike it again, you muffle those higher overtones.
The fundamental note is still there, but
But the total resonant energy is attenuated.
wow. So our expensive, highly shielded lab equipment is basically choking the bell. We are muffling the very lattice we're trying to measure.
Yes. The finite boundaries of our test masses and our shielded rooms damp the lattice harmonics. Therefore, the gravity we measure in a confined lab is always going to be a slight underestimation of the true geometric G0.
That makes total sense.
The 2.7% difference isn't a failure of the theory. It's the physical cost of putting reality in a box.
And that tiny 0.2% variance in the GPS data.
That represents the internal entropy, the harmonic loss within the satellite's own complex atomic clock apparatus.
Wow.
True unperturbed geometric gravity can only be fully accessed in unconfined, infinite resonance.
Okay, so what does this actually mean for us? I mean, if gravity is just the inverse of time density, and if resonance dictates gravity,
Then if we can figure out how to control resonance, we can control gravity.
and if we control
Not
gravity,
crucial time.
which brings us perfectly into the realm of practical application, because we're moving from theoretical equations to physical architecture.
We have to talk about how to build a machine that manipulates this lattice.
Let's talk about building it. The manuscript outlines the creation of something called a resonant cavity. But what is that, physically?
A resonant cavity, or a resonant vault, is defined in TDUFT as a strictly sealed physical enclosure, where standing acoustic or electromagnetic waves are generated and driven by specific harmonics.
Okay.
Throughout the text, the author frequently references the CEG musical triad.
A standard major chord, C, E, and G.
Exactly. When you drive these specific frequencies into the walls of a cavity whose physical dimensions are perfectly proportioned to those same frequencies, this unique field interaction occurs.
What happens?
The wave coherence inside the room, what the author calls the multiplicative field, begins to overtake the physical geometry of the room, which is the additive field.
Hold on, I need to make sure I have this distinction clear.
Hmm.
The additive field is just the physical shape of the room, like the length, the width, the walls.
It's just the raw geometry, yes.
Yeah.
The physical boundaries that dictate linear space. That is additive.
Okay.
The multiplicative field is the wave energy, the resonance filling the empty space inside those boundaries.
And if you pump enough of the right harmonic energy into the room, the waves become physically more dominant than the walls themselves. It's almost like the sound becomes more real than the stone.
When that multiplicative wave field overtakes the geometric field, it essentially creates a buffer against the external memory lattice.
A buffer.
It reduces the gravitational coupling inside the room. It drops the ambient normal gravity, G0, down to a newly suppressed interior gravity, G1.
And because G equals 1 over T to the fourth, dropping the gravity inside the room forces the time density to spike astronomically.
Precisely. And this relationship is formalized by what the author calls the decoupling factor, D.
Decoupling factor.
The math for the decoupling factor is very simple. It's just G0 divided by G1.
Oh, okay.
The weaker you make the gravity inside the room, the higher D climbs. And this factor D governs everything.
How so?
It inflates the time density inside the room by the square root of D, and it creates a literal time travel divergence by the fourth root of D.
So mathematically, reducing the gravity inside this room literally detaches the room from the normal flow of time outside the room.
That's the core mechanic, yes.
But I want to pause and ask a really practical question here, because I know people listening are wondering this. The manuscript also mentions using these same CEG harmonics to float massive 400-ton granite blocks, presumably to build the ancient monuments.
Right, the megaliths.
So if I go into my garage and I take a giant granite block and I somehow tune it to a CEG chord, am I time traveling, or am I just making a really heavy, really ancient hoverboard?
Distinguishing between those two applications is absolutely vital. It comes down entirely to scale and enclosure.
Enclosure.
If you pump the CEG harmonic into a solid granite block, you are matching its internal lattice modes. You're creating a standing wave entirely inside the stone that cancels its inertial response to the Earth's gravity.
So you're creating localized anti-gravity.
Yes, local inertial nullification. The block floats.
So hoverboard.
A hoverboard, yeah. But here is the limiting factor. The resonant field is confined completely to the molecular lattice of the stone itself.
Oh, I see.
The empty space around the stone and, the workers pushing the stone, they remain firmly anchored in normal ambient time. Their physical clocks are still locked to the universe.
Because there is no space inside the solid stone for a person to stand and actually experience the effect.
Exactly. True time travel, actual navigation through the memory lattice, requires a sealed, habitable cavity.
A room.
A room. You aren't just vibrating a wall, you are tuning the empty space contained within the walls.
Wow.
When the standing wave fills an enclosed interior volume, it traps the consciousness of the observer and the matter inside a newly shifted T field.
So floating a rock is just a parlor trick, of anti-gravity. But enclosing a space and floating the space itself with you inside it,
That's a time machine.
that is the precise architecture of decoupling.
It is.
Okay, so if sealed resonant cavities are the actual engines of time travel, Dukas argues that we've been staring at the blueprints for these engines for thousands of years.
We have.
And he doesn't start with some minor artifact either. He goes straight for a heavy hitter. He applies this physics to Noah's Ark.
Under the TDUFT framework, Noah's Ark is completely reinterpreted. It is not viewed as a wooden maritime vessel designed to survive a global flood of water.
No.
It is analyzed as a precise geometric resonance fault, engineered to survive a flood of time.
A time vessel. Let's look at the dimensions, because this is wild. The biblical text states the ark is 300 cubits long, 50 cubits wide, and 30 cubits high.
Right.
If you simplify that ratio, you get 30 to 5 to 3, or 3, 5, 30.
And in pure harmonic terms, the mathematical ratio of 3 to 5 is the exact blueprint of a major third interval in just intonation tuning.
Oh, wow.
It is the C to E harmonic dyad.
The C and E of our CEG chord.
Exactly. And the 30 represents a bass 10 extension, which in acoustics acts as a dimensional octave leap.
So the dimensions aren't arbitrary.
Not at all. Therefore, the arc's physical dimensions encode the exact harmonic frequencies required to generate the decoupling standing waves we just outlined.
But the wildest part of this section isn't just the dimensions, it's the math of the journey itself.
The Noah factor.
Yes, the manuscript refers to something called the Noah factor. The text says Noah was inside the ark for 40 days.
40 days and nights.
Right. But Dukas points to archaeological and historical records suggesting a massive gap of about 4,000 years of cultural evolution from the pre-flood world to the post-flood world.
It's a huge gap in the timeline.
Right. So inside the ark, 40 days of subjective time passed for the crew. But outside the ark, 4,000 years of collective human history passed.
And to physically achieve that level of extreme time compression to squash 4,000 years into 40 days, you run the numbers through the TDUFT decoupling equation.
Okay, what do you got?
The required decoupling factor D is staggering. It demands a D of approximately 1.78 times 10 to the 18th power.
10 to the 18th? That is a massive number, a quintillion.
A quintillion, yeah. It means the gravitational coupling inside the ark had to be suppressed by a factor of over a quintillion.
Unbelievable.
And as a direct result, the time density inside the ark was amplified by 3 billion times.
A billion times.
The ark wasn't just floating detached from time, it became a hyperdense region of space where memory and history accumulated at 1 billion times the normal rate.
Which allowed the human consciousness inside to safely sail over 4,000 years of external violent historical change while only experiencing roughly a month of physical duration.
Exactly.
It's absolutely wild to visualize. And he doesn't stop with the ark.
No, he doesn't.
He takes the exact same field mechanics and applies them to the Great Pyramid of Giza.
Oh, this part is fascinating.
He describes the entire pyramid as a ladder of resonance.
Right, because the ark was essentially a single unified vault. But the Great Pyramid is modeled as a highly complex, multi-stage temporal engine.
Well, multi-stage.
The different chambers are tuned to modulate time density in drastically different ways.
So the manuscript maps these individual chambers to specific harmonic ratios. For instance, the subterranean chamber, deep underground, is a 2-to-1 ratio.
A simple octave?
Right. Dukas says it's a grounding room, a stabilizer. It produces minimal time decoupling. But then you ascend into the king's chamber. And the dimensional ratio there is 5 to 3.
The inverse of 3 to 5.
Dukas calls this a sharp, high-gain time density spike. It can supposedly create a time divergence of 10 to 100 times normal flow.
It serves as the highest divergence node in the entire structure.
I was trying to picture what it would feel like to walk through this building, and it feels like looking at the tachometer on a high-performance sports car.
Okay, how so?
Like the subterranean chamber is like sitting in the driveway, just idling in first gear.
Right.
But the king's chamber is the red line. The needle is buried in the red. It's incredibly powerful. It's pushing the limits of the machine. But if you don't know exactly what you're doing, you are going to blow the engine.
Or, to use the terminology of TDUFT, you are going to violently fragment your consciousness.
Yikes.
The king's chamber is characterized as highly dangerous.
Because of that sharp spike.
Right. The sharp spike in memory time density means it was likely only ever suitable for highly trained initiates, individuals who knew the precise harmonic protocols.
Protocols like what?
Like specific acoustic vocalizations or exact breathing techniques required to maintain internal scalar stability while the external time field just sheared away.
But then the text details a hypothetical third tier, the apex room,
Right.
a hidden chamber near the very top of the pyramid tuned much closer to the golden ratio, phi.
Following your sports car analogy, if the king's chamber is the red line, the apex room is the smooth overdrive cruising gear.
Smooth cruising.
Right. A geometric space proportioned near the golden ratio naturally supports a much more symmetric, globally coherent standing wave.
So it decouples the space, but it does so far less violently.
Exactly. The time divergence might only be a factor of 2 or 3 rather than 100.
So it's safe. It's an integration room. You go there to cool down.
It's a controlled environment for consciousness to integrate high-density temporal experiences without making terrifying jumps through external history. What is deeply compelling here is how TDUFT completely strips away the traditional historical explanations for these megastructures.
They were never meant for holding water,
No.
and they were never designed as elaborate tombs for dead pharaohs.
They were literal vehicles.
Hmm.
Architectural machines designed for floating through the memory lattice, granting human consciousness the ability to navigate massive spans of history while experiencing very brief subjective time.
Okay, let's look at the mechanics of this. If we accept the premise that a 300 by 50 by 30 cubit room can act as an engine for time travel,
Okay.
how exactly does it work geometrically? Like, how do you actually step outside of normal time?
This brings us to a concept the manuscript calls the geometry of the gate.
The geometry of the gate. And it all revolves around one specific mathematical shape.
The 5, 12, 13 triangle.
Right. The 5, 12, 13 Pythagorean right triangle.
Within TDUFT, this specific geometric figure is designated as the neutral gate
But out of all the triangles in mathematics, why this specific one?
because it possesses a very rare, anomalous mathematical property.
Okay, let's hear it.
If you calculate the perimeter of a right triangle with sides 5, 12, and 13, you simply add 5 plus 12 plus 13.
Which is 30.
The perimeter equals 30. Now, if you calculate the area of that exact same triangle, the formula is 1/2 base times height,
So 1/2 of 5 times 12.
which also equals 30.
Perimeter equals 30. Area equals 30. The numbers are identical.
Bringing this back to the core TDUFT postulates, remember the two foundational fields.
The additive and the multiplicative.
Exactly. The physical geometric shape of the room is the additive field. That directly corresponds to the perimeter.
Right.
The wave energy, the resonance filling the room, is the multiplicative field. That corresponds to the area.
And the additive field governs linear time, t. The multiplicative field governs density time, t squared.
So in the unique case where perimeter equals area, the additive field perfectly equals the multiplicative field.
Linear time equals density time, t equals t squared.
Yes. This is the exact physical condition required to open a neutral time gate.
Wow.
It is the highly specific geometric condition where the resonant wave perfectly neutralizes the physical geometry, effectively collapsing ambient time flow entirely.
Okay, I follow the math of the triangle. But how does a 2D 5, 12, 13 triangle relate to a 3D box like the arc, which is 300 by 50 by 30?
It's all about the ratios.
Right, because Dukas uses this set of calculations. He takes the arc's length, 300 cubits, he divides it by 5, and then multiplies by 2, which gives 120.
Correct.
Then he takes the same 300, divides it by 12, and multiplies by 2, which gives 50.
Yep.
So he extracts the numbers 50 and 120, and naturally the hypotenuse would be 130,
A 51, 21, 30 triangle.
which is just a scaled-up version of the 5, 12, 13 triangle multiplied by a factor of 10.
Exactly.
Now, I have to stop here, because this is where a lot of people will check out.
I understand why.
To a layperson, dividing a ship's length by 5, then multiplying by 2, and declaring you found a secret time gate feels a lot like numerology.
It sounds like number crunching until you get what you want.
Right. It feels like shuffling numbers around until you magically arrive at the answer you wanted all along. So why does TDUFT treat this as rigid structural physics rather than just symbolic mathematical play?
That initial skepticism is entirely justified. It's exactly where many classical physicists would initially balk.
Right.
But within the strictly defined context of TDUFT, this isn't arbitrary symbol manipulation. The author defines this specific mathematical operation as a similarity transform.
A similarity transform.
The prime ratios of 5, 12, and 13 represent fundamental structural resonant modes within the vacuum lattice itself.
Oh.
When you build a massive physical structure like the arc to a 3:5:30 ratio, you aren't just building a box. You are physically forcing the empty space inside that structure to resonate with those exact frequencies.
So it's not just a box, it's a tuned instrument.
Right. The 51-21-30 triangle isn't a mathematical parlor trick. It represents the actual physical topology of the standing wave pattern that forms inside the arc when it is acoustically driven.
Wait, so the math is just describing the invisible shape of the sound waves trapped inside the box?
Precisely. The arc's geometry physically coerces the acoustic wave field to fold into that 51-21-30 shape.
That is wild.
And because that wave shape is a perfect similarity transform of the 5-12-13 neutral gate, the physical conditions inside the arc collapse into neutrality.
The wave and the geometry equalize.
Ambient time flow is neutralized. It's not magic, and it's not numerology. It's resonant acoustics applied to the deep fabric of space-time.
The arc's internal wave triangle is the physical key turning the lock of the universe's memory lattice.
That's the perfect way to phrase it.
Okay, so you turn the key, you achieve resonance, you've passed through the neutral gate.
You're in.
But what happens next? Where do you go? I mean, if you aren't pointing a rocket ship through empty physical space, how do you steer?
Steering in the lattice.
Right. This brings us to a fascinating concept TDUFT calls the polarity navigation matrix.
It is essentially a map of the multiverse.
A literal map. Dukas provides a literal grid of four-dimensional quadrants based on spatial polarity.
Yes. The author defines dimensional space as a matrix of four distinct operator states, governed by two fundamental polarities.
Okay, what are the polarities?
First, there is the additive polarity, which represents the natural bias or direction of time flow.
So forward or backward?
Basically.
Yeah.
Second, there is the multiplicative polarity, which represents the physical capability or the access a system has to time reversal.
Let's walk through these four quadrants.
Sure.
Quadrant 1 is mapped as +1, +1. Both poles are positive.
Right.
This state is defined as accelerated forward time. The gravity here is squared, g squared.
Very heavy, very fast.
Then quadrant 2 is mapped as +1, -1. This is normal forward time. Baseline gravity, just standard g.
This is our universe, the reality we wake up in every day.
Okay, Q2 is home. Then quadrant 3 is mapped as -1, -1. Both poles are negative. This is accelerated backward time.
And the gravity is inverted and squared, 1 over g squared.
And finally, quadrant 4 is -1, +1, normal backward time, inverted gravity 1 over g.
This four-quadrant matrix is structurally crucial because it explains why time travel is even theoretically possible for humanity.
Because of where we live.
Exactly. We exist in quadrant 2, +1, -1. The first +1 additive pole means our natural baseline bias is to move forward in time at 1 second per second.
Right.
But pay attention to that second -1, the capability pole.
Okay.
Because we possess a negative multiplicative pole, we possess the inherent physical capability to invert our gravity field through resonance.
Oh.
Our specific universe is uniquely privileged. It is structurally designed, out of the box, to allow for reverse time travel.
We literally have the hardware for it built in.
We do.
But looking at quadrant 3, the -1 state, accelerated backward time?
Right. Q3.
If you build your resonant vault, you tune it to Q3, and you hit the gas. What stops you from traveling infinitely backward?
That's a great question.
Do you just keep going until you hit the Big Bang? Do you hit a wall? What happens if you go too far?
The answer to that reveals the profound elegance of the TDUFT geometry. It's a mechanism the author calls the unity wraparound.
Unity wraparound.
Let's look at the simple math of Q3, -1, -1. If you add those two poles together, the additive result is -2.
-2.
That -2 represents your backward compounding acceleration.
Yeah.
You're speeding exponentially into the past.
Okay, flying backward.
But look at the multiplicative result. What is -1 multiplied by -1?
+1.
+1. The double negative yields a positive unity.
Wait, really?
Yes, and this has massive cosmological implications. It means that traveling backward infinitely, eventually, unavoidably, wraps around to positive forward motion. The universe, or the memory lattice, is not an infinite straight line stretching endlessly into an unknowable past and future. It is a closed loop.
The loop.
If a vessel accelerates backward hard enough and long enough, the fundamental geometry of the lattice eventually forces that vessel to wrap around and return to forward motion.
So you cannot travel to before the universe existed.
No, because the structure seamlessly bends back on itself.
That is mind-bending. Time is a loop, and we are just navigating the curves.
Exactly.
Which brings us to the ultimate application. Because we have the theory, we have the ancient blueprints, we have the geometry of the gate, and we have the multiverse map.
Now we need the ship.
Now let's look at the actual modern engineering specs that TDUFT provides for a spaceship mission.
It gets very specific here.
The manuscript details a hypothetical mission jumping backward exactly 100 years, specifically to the year 1926.
To physically execute a jump like this, you can't just use a single hollow box like the Ark. That is too primitive.
Too basic.
The author details a highly sophisticated three-region ship architecture.
Right, it's a nested structure. Let me break this down. Region 1 is the exterior space. This is the ambient universe, quadrant 2, normal time.
Outside the ship.
Right. Then Region 2 is the hull of the ship,
Wow.
including its near-field mass. This outer hull is actively driven by harmonics into Quadrant 3, the accelerated backward state.
That's the engine.
And then Region 3 is the cabin interior, the very center where the crew sits.
And that's crucial.
The cabin is actively compensated and firmly held at Quadrant 2 normal time.
T2, right.
So the crew experiences normal time, say, a 72-hour flight, while the ship's hull violently traverses 100 years of external memory.
Yes.
When I read this, I immediately thought of a deep-sea submarine.
The submarine analogy is highly illustrative here. Let's expand on it.
Okay, think about hydrostatic pressure versus temporal pressure.
Right.
The outer titanium hull of a submarine has to withstand the massive crushing pressure of the deep ocean. That ocean pressure is the Q3 accelerated time field.
It's violent, it's fast, it wants to crush everything.
But inside the cabin, the life support systems fight back to maintain surface pressure 1 atmosphere Q2.
The crew can sit there drinking coffee in total comfort while the sub dives into an incredibly hostile, high-pressure environment.
Exactly.
And just as a submarine requires complex ballast tanks, diving planes, and propulsion to navigate the depth and direction of the ocean, the TDUFT ship requires specific temporal controls.
How do you steer a time sub?
The primary navigational control is a mathematical variable called psi.
Psi.
Psi acts as your distance dial or your throttle. It determines the magnitude and the depth of the jump through the lattice.
Okay.
The secondary control is the phase of the harmonic standing wave.
A phase.
If you drive the ship's hull with a normal standard CEG chord, you propel the ship forward in time. But if you apply a 180-degree phase inversion to that chord,
Flipping the waveform.
exactly, flipping the waveform so it becomes an inverted CEG that acts as your reverse gear,
Ow.
it physically flips the hull's coupling from a positive memory stream vector to a negative one.
And this all ties into one of the most radical equations in the book, Ducas's new light equation. He redefines the speed of light, c.
He does. In standard Einsteinian physics, c is a strict, unbreakable, constant speed limit for mass moving through a vacuum.
Nothing is faster.
Nothing. But in TDUFT, the equation is rewritten as c is a function of t and phi q.
Okay.
Here, the speed of light is not a speed limit, it is a directional operator.
Okay.
It unifies velocity with memory vectors.
So what does that mean in practice?
It proves that time travel isn't a matter of accelerating a mass backward through empty space. It is a matter of navigating backward through memory streams.
Memory streams.
These streams are the dense time currents that act as the structural, physical memory of the universe.
Okay, let's look at the exact flight profile for the 1926 mission. The goal is to go back 100 years from the point of departure.
Step by step.
The crew sets the side dial to exactly 0.500.
Which calibrates the hull into an overdense state.
Right. They engage the inverted CEG phase, putting the temporal drive in reverse.
Hitting the gas.
They maintain the internal cabin time, the life support, for 72 hours. And the math dictates that the hull will traverse exactly 100 years of the memory lattice backward.
Perfectly synchronized.
After 72 hours, they turn off the drive, the decoupling field collapses, and they drop out of the lattice exactly in the year 1926.
Just like that.
It's laid out like a literal Apollo flight manual.
It completely shifts TDUFT from a philosophical thought experiment into a raw engineering problem. It provides actionable variables, acoustic frequency, wave phase, amplitude, and temporal duration.
But, you know, getting to 1926 is only half the battle.
It is.
You have to survive the trip, and you have to know how to get home. Which brings us to the final hurdle.
The return journey.
You've successfully engaged the drive, you've jumped through the memory streams, and you've arrived in the past. But the lattice is not a calm, empty highway.
No, it is full of temporal turbulence.
It's turbulent.
Extremely turbulent. Navigating the lattice is not like cruising on a highway. It is like flying a small plane through a Category 5 hurricane.
Jeez.
The lattice is filled with dense memory corridors, high-pressure coronal zones, and complex branching historical junctions.
Branching junctions.
The structural integrity of the vessel is paramount. If the ship loses stability at any point during the flight, the result is a catastrophic failure the author calls temporal fragmentation.
Temporal fragmentation. That sounds like a very clinical term for a very bad death.
It's the worst-case scenario. To prevent it, the ship must actively maintain 3 distinct, overlapping layers of stability.
Okay, what are they?
First is geometric stability. The physical hull of the ship must be built to perfectly resist the crushing physical distortion of the time density gradients.
Such a strong metal.
Second is scalar stability. The internal standing waves must be reinforced and constantly monitored to prevent the resonance from collapsing inward.
Keep the sound pure.
Exactly. Third, and perhaps most difficult, is harmonic stability. The C-E-G ratios must remain locked in perfect tune. If the frequency drifts even a fraction of a hertz due to external pressure, the ship loses its grip on the memory stream.
So you managed to hold it all together. You arrive in 1926, you do whatever you came to do, and now you have to go home. You have to return to your present.
Right.
How do you safely drop out of the lattice without being destroyed by the sudden shift in physics?
The manuscript gives a highly specific 6-step return sequence to safely re-enter ambient Q2 time.
Let's walk through them because this sequence demonstrates the extreme mechanical rigor of the theory.
Step 1 is gradient flattening. You cannot just hit the brakes. You have to slowly bleed off the time density differential between the hull and the ambient universe.
Okay, easing off.
Step 2 is density decompression. You systematically let the temporal pressure off the hull, much like a diver slowly surfacing to avoid the bends.
Makes sense.
Step 3 is scalar restabilization. You have to rebalance the internal wave fields to match the incoming ambient reality. Step 4 is harmonic relocking, transitioning the acoustic drive from the inverted CEG back to baseline.
Back to forward gear.
Step 5 is boundary re-anchoring.
And step 6 is gate node realignment. Re-entering the neutral gate to finally step back into linear time.
That's the full sequence.
It is an incredibly complex, unforgiving sequence, and I have to ask, what happens if they mess up?
It's bad.
Say the crew executes the first 4 steps perfectly. They flatten the gradient, they decompress, but they fail at step 5, boundary re-anchoring. What actually happens to them? Do they just cease to exist? Do they become ghosts haunting 1926?
Failing to properly re-anchor boundary integrity is perhaps the most terrifying prospect in this entire framework.
Oh, man.
It leads to a phenomenon the author clinically refers to as echo-duplication, or partial re-entry.
Echo-duplication.
The vessel and the crew do not become ghosts in a traditional spiritual sense.
Yeah.
Rather, their informational mass, their very data, smears across the memory lattice. They might exist simultaneously, yet vaguely, across multiple overlapping historical timelines. Or their temporal footprint might violently fragment into thousands of disconnected microsecond echoes.
Oh, wow.
It is a total irreversible loss of chronological coherence.
Smearing across the lattice, like dropping a wet painting on the floor.
Exactly like that.
That is a chilling image.
But it highlights a crucial point about the depth of TDUFT. Entering time, jumping into the lattice, is actually the easy part.
Really?
Yeah, it just requires a massive amount of resonant energy and the correct structural geometry.
Right.
But the physics of safely decompressing, carefully decelerating, and perfectly resynchronizing your local time field with the massive indifferent ambient universe.
That's the hard part.
That is an engineering nightmare. It shows that George James Dukas has thought deeply about the thermodynamics and the field mechanics of a return journey, not just the fantasy of departure.
Wow. Okay. Let's take a breath.
Yeah.
We have covered an astronomical amount of ground today.
A lot of ground.
We started with the foundational postulates of TDUFT, that time is dual-layered, consisting of linear flow and informational density.
A vinyl record.
Right. We saw how increasing that time density collapses gravity, solving the GPS satellite mystery without needing Einstein's space-time curvature.
Yep.
We explored the geometric blueprints hidden in Noah's Ark and the Great Pyramid, utilizing the 5, 12, 13 time triangle to create a neutral physical gate.
The neutral gate.
We mapped the multiverse through the 4 polarity quadrants, discovering that our universe is uniquely built with a reverse gear.
Q2 capability.
And finally, we piloted a dual-layered submarine-style ship through the turbulent memory lattice all the way back to 1926 and learned how to survive the terrifying re-entry sequence.
It is a breathtakingly cohesive framework. Whether one accepts it as literal, actionable physics or views it as a magnificent piece of speculative architectural philosophy, the internal consistency and the sheer scale of the theory is remarkable.
It really is.
It forces us to ask entirely new questions about the nature of our reality.
And for you, listening right now, that is exactly why we do this. We take these incredibly complex, esoteric, dense documents, and we extract the absolute best aha moments just for you.
We want to give you that shortcut to seeing the universe from a completely different angle.
Yeah. And, if we truly consider the central premise of this document, that time is not an empty physical dimension we move through, but a literal memory lattice that we navigate.
Right.
It leaves us with a profound implication about history itself.
I know exactly what you're thinking of.
Yeah. The manuscript insists that we travel through memory streams.
Mm-hmm.
So, what happens if a vessel navigates into a forgotten memory stream?
Oh, that's a wild thought.
Right. If a memory, a historical event, or an entire civilization is completely lost to humanity and erased from all our records, does that physical pathway in the lattice collapse and disappear?
Or does it stay there?
Right. Is the lattice itself the ultimate hard drive? Is the lattice the only place where true history is permanently stored, independent of human minds, just waiting in the dark to be sailed again?
If the lattice is the structural memory of the universe, then nothing is ever truly lost. It is only waiting for someone with the right harmonic key to find it.
We usually expect reality to be like that falling apple, clean, visible, and predictable. But maybe reality isn't the apple falling through empty space at all. Maybe reality is the invisible lattice of memory catching the apple, holding on to the moment it fell, forever.
I love that.
Thank you for taking this deep dive with us. Keep questioning the consensus, keep looking for the hidden geometry, and we'll see you on the next deep dive.